Welcome to Spring LIB.
So this is a constant acceleration problem. Let's start by writing down the givens. First given is that the angular acceleration of shaft A is 6 radians per second squared. And if you remember a ball falling from physics, it's essentially this. It's very similar. That's linear. This is angular. Here we go. Also, the speed of shaft, or the angular velocity of shaft B at some time is 400 RPM. And just want to point this out, T1 is going to be our answer. We're given 3 cases. I'll make a table later, and we'll calculate T1 for each of those cases. But I'd like to change or convert 400 APM to radians per second, since that's what we got acceleration in. So we are going to actually do this properly. 400 rotations per minute. We're going to multiply that by 1 minute is equal to 60 seconds. And 1 rotation is equal to 2 pi radians. Which I'm going to leave in terms of pi for the sake of precision. So we're going to say that the final speed, I say speed, but I should be saying angular velocity that we're looking for is 40 pi over 3 radians per second. That's the final speed. That's what we're going for. T1 is the answer. And let's remember that, wow, that is an ugly, ugly circle. Just in general, when you have 2 gears and a belt between them, this is gear A, this is gear B. That the relationship between their angular velocities is that the angular velocity of A of gear A multiplied by the radius, or in this case we're actually going to use the diameter, of wheel A is always equal to the angular velocity of wheel B times the radius of B. So we know our final angular velocity of B. So let's find out what that is in terms of velocity A. So the angular velocity of B at all times equals the angular velocity of A times the radius of A. Actually, we're going to use the diameter divided by the radius of B at all times. So we could also say, we also say that the angular velocity of A at any given time is going to be the angular velocity of A, that constant angular velocity we're given multiplied by time. Normally we'd also add the initial angular velocity, but in this question that is 0. So the angular velocity of A at any time is 6 radians per second squared times the time t in seconds. So we know so we're going to say that the angular velocity of shaft B at any time equals what's angular velocity of shaft A? 6 radians per second t multiplied by r a over r b. And now we have this general equation. We can solve for this case up here and find t1. So we're going to say that angular velocity of b at some time t1 equals RA over RB times 6 radians per second squared t1 and that we also know is equal to 40 pi divided by 3 radians per second. So solving that for t1, we have t1 equals 40 pi over 3 radians per second divided by RA divided by RB times 6 radians per second squared. And just real quick, checking my units, that will end up being unitless, and T1 will be in seconds, so we're fine there. And this question asks us for 3 cases. Case 1 has RA, RB, T1. Let's write that a little neater, shall we? T1. Case 1 is RA is 4 inches, RB is 2 inches. Case 2 has RA is 3 inches, RB is 3 inches. Case 3 has RA is 2 inches, RB is 4 inches. So we're going to plug these values back into this equation. I'm going to bust out the calculator. And I know that this could be simplified and written better, but I'm just leaving it like this because it helps me to remember all the steps of this problem up here. So I'm going to write 40. Oh, yeah, real quick. So these are actually the diameters, but I did mention this before. This is also true with regard to diameters. It does not it does not matter if you use diameter or radius of those gears, as long as it is consistent. If one of those is if one of them is the radius and the other is the diameter, you will get this problem wrong. Anyway, for case 1, I have it actually punched in already. The answer I get is 3.490. All of the values in this question were given as single digits, so I'm going to assume infinite precision and just return 3 sig figs. In that case, it is 3.49 seconds in case 1. Excuse me as I punch in case 2. 6.98 seconds. Actually, I got 6.980. Again, 3 sig figs. And for case 3, I got 13.96, so I'm just going to round that to 14.0 seconds. And in this case, or in this question, I'm going to say that this entire table is the answer. In general, so in general, for this question, we solved for the general case. We figured out what the answer was going to be, given the three different cases just in general, then plugged it in, got these answers. And that's all for this question.